So in this section, we'll be treating Python numbers. And when we are talking about Python numbers, Python has three built-in numerical data types, and they are integers, floats, and complex. So without further ado, let's look at each one of them. So starting with integers. What are integers? Integers are simply whole numbers. And for example, our age is an integer value. So here, if I'm to say age equals 65, this right here qualifies as an integer. And for us to check, we can easily check for the type of that data type, of the variable rather, and that's using the type function here. We can easily check the type of whichever variable that we set inside of it. So I'm just going to run the app, and as you can see here, it's giving us class int, which shows that it is truly an integer. So integers in Python are simply whole numbers. Now let's move on and let's see what floats are, or floating numbers. Now floating numbers are numbers that have decimal points. Floating numbers are numbers with decimal points. So for instance, let me say quantity, and here let's say 3.76. Now if we are to check the type of the variable as well, to just verify that it is truly a floating number. As you can see here, we have float. So that is simply what a floating number is in Python. So the floating number are decimal numbers, and it can either be positive or negative. So something that we need to take into consideration is, even if I'm having negative here, this is minus 65 minus 3.76, it still qualifies as an integer and as a float. So that's just something that I just want to quickly mention. Okay, so the third data type is actually the complex data type. Complex data type. And when we're talking about the complex data type is a type of data type, is a data type that has both the real part and the complex part. So we can have something like this. Um, Let me just say num equals to 5 plus 6j. And this is a complex number. And if we are to check the data type as well, we can see it is of the class complex. So these are the various ways that we can have our number data types. We can have them as integers, which are whole numbers. We can have them as floats, which are numbers that have decimal places, and we can also have them as complex numbers. So these are the three built-in numeric data types that we have in Python. So before we round up this section, let's quickly look at the different or the major arithmetic operations that we can perform with numbers. So here I'm just going to have this here say arithmetic operations, and here we'll be looking at them one by one. So I'm just going to set some constant or let me say values that we're going to be using, not necessarily constant. So I'm just going to say x equals 6 and y equals 9. So here The first arithmetic operation we want to look at is addition. Or let me just say addition, and we'll just be printing them out. So for addition, I can say x plus y, and right in front of it, I'm just going to say addition. We use the plus sign for addition. Then we want to look at subtraction, where we use the minus sign, and that's subtraction. Then we can also perform multiplication as well, x times y, and we have it as multiplication. Then we can also have division right here, division. And we can also have integer division, where we use two forward slashes to show our integer division. So integer division, and I'll be explaining the difference between division and integer division in a bit. So here we also have modulus, which I will also be explaining in a bit. Okay, so modulus, and we have exponentiation, so which is also known as power, where we use two asterisks to define that. So exponentiation. Okay, so these are the basic arithmetic operations that we have in Python. So I'll just be commenting them out one by one, and be running them one after the other. So here we have x plus y. Remember, our x is 6 and our y is 9. So if we run that, 6 plus 9, that would give us 15, which is how it ought to be. So now let's look at subtraction. 6 minus 9, that would give us minus 3. Let's look at multiplication and division together. Okay, so 6 times 9, that's 54. 6 divided by 9, that's 0.66666. Okay, guys, so now as we can see, now let's move to integer division. Now, the difference between the regular division or the normal division that we know and the integer division is that the normal division that we know would give us the division, or the actual division, where we have the quotient and the remainder. Meanwhile, when we are working with integer division returns the quotient for us, which means if we are having 4 divided by 3, and integer division, if we are using integer division in this case, 4 integer division 3, that's one remainder. Our normal division, 4 divided by 3 is 1 0.3333. 4 divided by 3, 1.333. But when we are making use of integer division, that will give us the quotient alone, which is 1. So here we are dividing 6 divided by 9. Our normal division is giving us 0.6666. But right here, our integer division is going to give us 0, which is the whole number here. So what the integer division is doing is, out of the whole division, it is just taking the whole number, and it is just doing away with the whatever the decimal point is. It doesn't care what that is. All it takes is just the whole number right here. And here it is 0. So that is why we are having 0. Now, modulus does the opposite of what the integer division does. So what modulus would perform is, the modulus would actually return the remainder of the division for you. So here we are having, definitely we know that when we divide 6 divided by 9, that would give us 0 remainder 6, because um, you can't divide 6 by 9. So the remainder we're going to have is still going to be 6. So here it is giving us that, okay, we can't divide it and the remainder is still 6. So for better understanding, I'm just going to change the numbers here. I'm going to make x 7 and I'm going to make y 4. And I'm going to run that once more so that we can have an understanding. As you can see here, our normal division is giving us 1.75. Our integer division is giving us 1, which means 4 can go in 7 just one time. So it's giving us the quotient right here, and the remainder is 3, because when 4 goes in 7 once, the remainder is going to be 3. So here, the integer division returns the quotient, the modulus returns the remainder. And lastly, let's look at exponentiation, which means power. So here we are saying 7 raised to power 4. That is just what we are saying right here. And if we run that, we'll definitely see the result right here. Okay, guys, so basically this is just what Python numbers is all about, the basic of Python numbers and functions, arithmetic operations that we can actually make use of. Okay, so before we end this section, let me just quickly add a little bit of something, and that thing is the math library in Python. The math library in Python is a very, very useful library that helps us to do a whole lot of stuff. So I'll just be showing us a bit, and for us to work with the math library, the first thing that we need to do is import it at the top of our program file. So here I'm just going to be importing it. So for me to import it, I'll just say import math. So with that, I can make use of the math library. So here, the math library has a whole lot of functions inside of it. So I can say math dot, and here if I say pi, this returns the constant for us, the constant pi. So if I'm to print this out, let me just print that out and say math dot pi, and I'm to run that, I can definitely see it here, 3.14159, and that is our constant pi. Another thing that we can have is we can also check the square root of, so here we can say math dot sqrt, and here we can check the square root of a number. So if I say 9 and I'm to run that, as you can see, we're seeing 3.0. And we have so many functions that we can work with in the math library. Even when we are talking about exponentiation, math.power, and I can say 3 comma 5, which here I'm saying 3 raised to power 5. So that is what I am doing right there. And if I run that as well, I am saying 243 right there. So 3 raised to power 5, 3 times 3 times 3 times 3 times 3, that's 243. Okay, so there are a lot of math functions that we can actually take advantage of. So if we are to scroll, let me see. So if we are to, here you can see we can check our cos, arctan, pi, infinity, we can make use of exponentiation and so on. So we have a whole lot of them. Then let me quickly talk about some few ones that we could actually find important. The seal um, and the floor method. So I'll just show us that those two quickly before we round up this section. Okay, so what the seal does is it rounds up any decimal number to it rounds it up. That's what it does. So if we have, let's say we have 7.9, and what this does is it rounds it up to 8. So whatever number that it has, it just rounds it up. Even if it is 7.1, this would become 8. If I'm to come here and do 7.1, this would actually round it up to 8. So this, there's also, let me add this as well. There's also a math function that we actually use for approximation. And this works normally. So if I say 7.49, me let me comment this out. Am I getting it right? Okay, just the round function. Yeah. So we can make use of the round function, and the round function automatically rounds up our number. It approximates it rather. So it approximates it. So here, what it does is it um approximates properly. So it approximates zero from 0 to um 0.49. That would be equal to 0. Then it approximates 0.5 to 0.99 to be equals to 1. So that is how the round function works. So if I have 7.49, that would give me 7. So it rounds it to 0. Then if I have 7.59, this would give me 8. As you can see, the normal approximation that we know. But the situation is different when we are talking about seal and floor. What seal does it approximates the number, it approximates whichever number in the decimal place, that's from 0 to 0.0 to 0.99. It approximates it to 1. So which means even though this is 7.1, during the approximation it is going to give us 8, just like this. So whether we're having 7.4, 7.5, 7.8, is going to still give us 8. And that is what the seal function does. Now, the floor function does the exact opposite, in the sense that it approximates from the old decimal number, the decimal places, it approximates it to 0. So it rounds it down. So whichever number that we have right there, so even if it is 7.9, it is going to round it down to 7. So the basic difference between this is the round function performs the approximation the proper way that we know it. 0.0 to 0.49, it rounds it to 0. 0.5 to 0.99, it rounds it up to 1. But the seal function rounds everything up. So from 0.0 to 0.99, it rounds it up to 1. Whereas the floor method or rounds up everything down, or rounds it up to 0. Let me put it that way. So the floor function, even though we're having 7.9, will actually round it up to 7. And the seal function, even though we're having 7.1, will automatically round it up to 7. So that is the difference between these three functions. So in the math library, we have a whole lot more functions that could do a whole lot of things for us. So I would implore you guys to just explore that particular math library and see the various things that you can work with right there, which will be useful as you walk along in your programming journey.